All right, here are solutions for perfect problem 6 for Math 111. You're given this mess of a polynomial and basically asked to factor it completely. Make it x minus 1 times x plus 1 times x minus 2 times x plus 3 times x minus something else. We got to figure out what that something else is. And the way we're going to figure that out is by doing long division over and over and over again. So first we're going to take this polynomial, this x to the 5th minus 3x to the 4th minus 11x cubed plus 27x squared plus 10x minus 24. We're going to divide it by x minus 1. Okay. Set this up, polynomial long division. The way you do this is we want to first get rid of this x to the 5th. We're going to work from the left to the right. So to get rid of this x to the 5th, we need an x to the 4th up here because x to the 4th times x is x to the 5th. X to the 4th times negative 1 is negative x to the 4th. And now, just like I do with regular long division, I'm going to subtract. Negative 3x to the 4th minus negative x to the 4th is the same as negative 3x to the 4th plus x to the 4th, which is negative 2x to the 4th. Note that x to the 5th minus x to the 5th was nothing, so I didn't have to write anything here. And all of these, negative 11x cubed minus nothing is just negative 11x cubed, so I kind of just brought it all down. If that made sense, you're good, because you just got to do that over and again and again and again. Same thing, except now, instead of getting rid of x to the 5th, I want to get rid of negative 2x to the 4th. To get rid of negative 2x to the 4th, I need a negative 2x cubed up here. And the reason I need negative 2x cubed is because negative 2x cubed times x is negative 2x to the 4th. Negative 2x cubed times negative 1 is positive 2x cubed. And now I subtract. Negative 2x to the 4th minus negative 2x to the 4th, those just cancel out. Negative 11x cubed minus 2x cubed is negative 13x cubed. And I can just bring down the rest of this stuff. And I repeat. I want to get rid of negative 13x cubed. I better put a negative 13x squared up here so that negative 13x squared times x will give me negative 13x cubed. Negative 13x squared times negative 1 is positive 13x squared. And subtract. These cancel out. 27 minus 13 is 14. I want to get rid of 14x squared. I better put a 14x up here. 14x times x is 14x squared. 14x times negative 1 is negative 14x. And subtract. 10 minus negative 14 is the same as 10 plus 14, which is 24x. To get rid of 24x, I need a 24 up here, because 24 times x is 24x. 24 times negative 1 is negative 24. And now if I subtract, I get 0, which is good. That tells me that this polynomial is this polynomial times this polynomial. So what I want to do is now divide that quotient by dividing find r by first dividing f of x by x minus 1. That's what I did. Then dividing that quotient, which is this answer up here, by x plus 1. Okay. X plus 1 divided by x to the 4th minus 2x cubed minus 13x squared plus 14x plus 24. To get rid of this x to the 4th, I need an x cubed here. X cubed times x is x to the 4th. X cubed times 1 is positive 1x cubed. Subtract. Cancel out. Negative 2 minus 1 is negative 3. Get rid of this negative 3x cubed by putting a negative 3x squared up here, because that times x gives me negative 3x cubed. Negative 3x squared times 1 is negative 3x squared. Subtract. Negative 13 minus negative 3 is the same as negative 13 plus 3, which is negative 10x squared, plus 14x plus 24. Get rid of this negative 10x squared by putting in negative 10x up here and multiplying that by x, you get negative 10x squared. Negative 10x times positive 1 is just negative 10x. And subtract. 14 minus negative 10 is the same as 14 plus 10, which is 24x. To get rid of this 24x, I'd need a 24 up here. 24 times x is 24x. 24 times 1 is 24. I get no remainder. That's a good thing. Means I'm doing everything right so far. Next step is to take that quotient. So this x cubed minus 3x squared thing, x cubed minus 3x squared minus 10x plus 24. And divide that by x minus 2. Okay. X minus 2 divided by this mess. X cubed is what I want to get rid of. I better put an x squared up here. X squared times x is x cubed. X squared times negative 2 is negative 2x squared. Subtract. Cancels out. Negative 3 minus negative 2 is the same as negative 3 plus 2. Negative 3 plus 2 is negative 1. So I got negative x squared minus 10x plus 24. To get rid of this negative x squared, I need a negative x here. Negative x times x is negative x squared. Negative x times negative 2 is positive 2x. I subtract. These cancel out. Negative 10x minus 2 more is negative 12x. To get rid of this negative 12x, I need a negative 12 up here. Negative 12 times x is negative 12x. Negative 12 times negative 2 is positive 24. And if I subtract, I get 0. Awesome. All right, I think I'm a step away. It now says divide that, and finally divide that quotient by x plus 3. So take your answer here, maybe we'll go back to blue, and say x plus 3 divided by x squared minus x minus 12. To get rid of this x squared, I need an x here. X times x is x squared. X times 3 is 3x. And subtract. Negative x minus 3 more x is negative 4x. To get rid of this negative 4x, I need a negative 4 here. Negative 4 times x is negative 4x. Negative 4 times 3 is negative 12. I subtract. I get 0. I am happy because I am done. What I found out is that when I divide from this thing, if I divide out the x minus 1, the x plus 1, the x minus 2, and the x plus 3, all I'm left with is x minus 4. In other words, r equals 4, or f of x equals x plus 1. No, x minus 1 was the first one I did. Times x plus 1 times x minus 2 times x plus 3 times x minus 4. Whew, that's a lot of polynomial long division, but I guess it's a lot of practice. So that is the end of this perfect problem.